About what is the value of the viscous force, right? That is, when viscosity is there, how much force acts. So viscous force between layers. So the viscous force between layers depends on, this force depends on a few things. Number one, understand what is each factor step by step, so you can get the whole relation. So the first thing that it depends on is the velocity gradient. See, what happens is that when the liquid is flowing in layers, let's say, right, and if all layers are flowing with the same speed, then there is no need of a viscous force between the layers. I hope everyone gets that, because everything is moving together. But only when the velocities in different layers are different, at that time there will be a viscous force between layers. That is, layer 1 will try to pull layer 2 and vice versa, then layer 2 will try to pull layer 3 and right? So if you consider, if you would consider a situation like, let's say that in one case we have it like this, that the uppermost layer is moving with the speed, suppose 5 meters per second, and the lowermost layer is moving with the speed 1 meter per second, and let's say this depth is 1 meter. So overall the gradient is 5 minus 1 by 1. You understood what I did? Delta V by delta Z, right? But in another case, suppose it's that in the same vessel or in the same tube, same river, same pipe, whatever. Let's say it's flowing slowly, so suppose this is only 3 meters per second, and let's say this is like half a meter per second, 0.5 meters per second. So then the difference is, the gradient is as follows. So what happens is that when the gradient is high in a situation like this, because the layers, they are moving at more different speeds or different rates. So like one is going quite fast, the other is going a little bit slower. The differences are more. Now when that happens, the liquid will try to pull each other more. The liquid molecules will try to pull each other more. Now that is because whenever two things are moving, it's not collision of course, but does have similar principle. If you think that there are two balls, let's say, moving in the same direction, and suppose this is moving with 5 meters per second and this is moving with 1 meter per second. Okay, so when the difference of their velocities is big, when they will interact with each other, they will apply more force. On the other hand, if the difference of their velocity is very small, I hope that you realize what I am saying. Yes. Right? So that's what we have here as well. So when the difference of velocities is more, the interaction between two objects will give a stronger force. That is what happens most of it. So that's why higher velocity gradient means more viscous. That is, when all the layers are moving at the same speed, no viscous. But when they are moving at a lot of different speeds, there will be more viscous. So the viscous force, you can see, it depends. It's proportional to dV by dz or delta V by delta Z. Did you understand what I have written here? Delta V by delta Z. Instead of that, you could also write dV by dz. Clear what I'm saying? dV by dz. That is velocity gradient. Okay? Yes. The other thing that becomes very important in this context is area. Right? If you think of the top view, let's say here, you go over here and you watch it from this side, you're going to see one surface like this, let's say. Now if that surface is filled with molecules, so let's say these are the molecules on that surface or on the upper layer, and just like that there will be molecules on the lower layer also. So do you realize that if the area is more, there are more molecules? Yes. And if there are more molecules, there will be more attraction between molecules. Fairly simple, don't you think? Almost common sense. More number of molecules will be attracting more, right? They will have total force higher. So that's why, because so indirectly what we have is if area is more, that will give more number of molecules, and more number of molecules in turn give more viscous force. So the second thing that the viscous force depends on is area of each layer. Right? Bigger area, more viscous force, because there are more molecules. Number 3. The third one is it depends on what material we are talking about. That is, what is that fluid? Different fluids will have different properties, right? So oil, water, although both are fluids, but their intermolecular forces are not going to be same. Everyone agrees with that? So because of that, the viscous force obviously also depends on material. And number 4, it would also depend on temperature. It would also depend on what? I'm sure you have studied this in chemistry, that in gases, for example, real gases, there are intermolecular forces, correct?
Yes.
And these intermolecular forces, they are not always same. They depend on temperature to some extent, correct? The same is true for liquids also, right? Even in liquids, what happens is, as you heat something, as you heat a liquid, the molecules start to go away from each other. That is, their intermolecular attraction will decrease. A point will come where the intermolecular attraction becomes very less, and the gas will, the liquid will vaporize. It will be evaporated. Correct or not?
Yes.
So, the intermolecular attraction depends on temperature, and that is why viscous force between layers also depends on temperature. Right? 4 factors clear? Right? Now, all of this can actually be summed up in one formula. Let's see what's that. So here, just like I wrote Fp proportional to dV by dz, I could also write Fp proportional to A. Alright, I could write Fp proportional to A. Got it? That is more the area, more the viscosity. So when we combine these equations, right, when we combine these things, we get Fv is proportional to area and also proportional to dV by dz, or delta V by delta Z. And generally when we have proportionality, we like to remove that proportionality and we like to write a constant. So here I am going to put a constant. And that constant is nothing but eta. Okay? This is read as eta. 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 Right? And along with it we have to put a minus. Why are we putting a minus sign? That I'll tell you now. Right? First of all, let me tell you about eta. So what is eta? Eta is nothing but the coefficient of viscosity. Generally, coefficient means a constant or an extra number that you are getting within an equation. So this eta is the coefficient of viscosity. Now, if you realize, I told you that it depends on 4 things, but you don't see these two in that formula. Well, they are there, indirectly. What I mean is that this coefficient of viscosity is obviously property of material. It is a property of material. Material, that is, if it's water, then eta's value will be different. If it's oil, different once again. Understood? For every fluid, the value of eta will be different. It's a property of material. Just like density is property of a material. Got it? One more. This eta itself depends on temperature. Eta itself depends on temperature. That is, as temperature changes, for every material, the value of eta will change. Now, how does it change? Whether it increase, decrease, that we are going to talk about. Right? So, for every material, the value of eta is different. So, it's a property of material. Not only that, it changes with temperature. So, I hope you now realize that these 3 and 4 are indirectly included in that formula. Right? So, velocity gradient, area, material, because coefficient of viscosity is property of material, and finally temperature, because eta depends on temperature. Understood? So this is the formula of viscous force between two layers. You can also write delta V, delta Z, no problem. Now why that minus? The reason is very simple. Is that if you think of fluid flow, let's say like water flowing in a river, generally what happens is that the uppermost layer is fastest and the lowermost is slower. Or where it comes in contact with the pipe, it is slower. So it is that as depth will increase, Z stands for depth. As depth will increase, the speed is going to decrease. As depth will increase, the speed is going to decrease. So if you think of this quantity, delta V by delta Z or dV by dZ, this will generally be negative. I hope that makes sense to you. Why? Let's try putting some value. Suppose this depth is 1 meter. And here, let's say the speed is 5 meters per second. And here, let's say the speed is 1 meter per second. So let's say we go from the point A to the point B. Initial final. So delta V means 1 minus 5, isn't it? And depth increase, delta Z means change of depth. So final depth 1 meter minus initial depth 0. See, it turns out to be negative. Sorry, minus. It turns out to be negative. So that's the point I made. Is that you find that in most situations delta V by delta Z is negative. So what if you don't write this? Nothing. It would mean every time eta's value will turn out to be negative. We don't like that. Generally when we say that we have got a coefficient or we have got some property of material, we like to keep it positive because it's very cumbersome to write negative values everywhere. For example, you want to make a chart of coefficient of viscosity. તો બધી જગ્યાએ minus this, minus this, minus this, minus this. એવું લખવા કરતા એની definition જ બદલી નાખો ને. Make sense or not? If you recall bulk modulus, you will recall what I am saying. એમાં એવું આવતું. B is equal to minus into V into delta P by delta V. So why was there minus? Because as pressure will increase, volume will decrease. So similar reason over here also. Okay, so that's why we are putting a minus. Okay, so that's the formula of viscous force between layers of a fluid. Again, it is just like friction. It's that as long as there is relative motion, if every layer moves at same speed, there is no viscous force. Only when the speeds are different, at that time you are going to get a viscous force between the layers. Alright? Right? You can actually find out the unit of eta based on that formula. Right? So if you want to find out the unit, it's going to be Newton for force. dz for depth means meter when it will be multiplied on that side. Velocity divided on this side, so meter per second. And area divided on this side, so meter square. So meter would get cancelled here and you get Pascal second. Isn't it? I hope that's clear. So SI unit of eta. What is the SI unit of eta? Pascal second. SI unit of coefficient of viscosity is Pascal second. You can also find dimensions and all that based on this formula. Right? So possible earlier you would have memorized it. Okay, now you can see there is no need. If you know this formula, you can always put force dimensions or force units, area dimensions or units, speed and distance, and you can get whatever you want. Right? Okay, so that's it. Now, one CGS unit is important. Okay, CGS unit of coefficient of viscosity. You may have studied this in chemistry, I'm not so sure. It's called 1 point. How is the points chemistry mark? It is the CGS, right? So obviously this 1 point is nothing but dyne per centimeter square into second, right? I hope you understood why. Pascal is like Newton per meter square. Instead of Newton, dyne. Instead of meter square, centimeter square. And second is section. Fine. Okay. Now let's technique. Actually, there is a question which we could solve based on this example. Then we'll do that. Try to remember this formula, everyone. એવું લગાવવાની જરૂર છે લખી લેજો ને જાતે એ તો લખી લેવાની બધામાં નો ખબર પડે તો પૂછી લેવાનું કે આમાં શું F means what? Viscous force between layers of fluid. Okay, eta coefficient of viscosity, A for area of the layer, dV by dz or delta V by delta z is velocity gradient. Even if you write delta, it's fine really. Okay, book માં તો D લખતા જ નહીં મને ખબર છે. They hate mathematics, right? આ બુકના જે ઓથર છે એ લોકોએ બધી ટ્રાય કરી કે જરૂર પડે તો એક આખો પેરેગ્રાફ લખશું પણ એક ઇક્વેશન નહીં લખી. ઓકે, they'll explain everything in paragraphs કે આમ થાય આમ થાય આમ થાય. એના બદલે એક ઇક્વેશન થી બે લાઈનમાં ડિરાઈવ થતો હોય તો એ નહીં કરવાનું. They try to explain everything in words. કેટલી જગ્યાએ છે ને ઇન્ટિગ્રેશન ની જરૂર પડે કરવા. ઇન્ટિગ્રેશન એનો ખાલી વર્ડ માં લખી નાખ્યો હોય if we integrate we get દેખાડવાનું નહીં કે આવું ઇન્ટિગ્રેશન થાય, right? Actually they are trying to hide the maths portion or maths part of physics. Okay, sometimes I remember in 12th standard a couple of places where we are actually doing integration, they still don't write the word. They just say if we take a sum, integration is a sum, agree, there is no doubt about that, but still they are a little bit different, right? You cannot add just like you do integration. Okay, but still they write if we take a sum, but you correct integration. Okay, so that example, which one? Block water. 10.9. So metal block of area 0.1 meter square is connected to a 0.010 kg mass via a string that passes over an ideal pulley considered massless and frictionless. Although ideal as well, as in figure given above, right? I hope you can see the figure. Okay. So first of all, let's draw the figure and see what's going to happen. Okay, so this is what we have, and then a liquid with film thickness 0.3 mm is placed between the block and the table. So before placing this block here, first someone has spilled some liquid. Understood? Someone has spilled some liquid everywhere, and now the block is to be placed. So what will be there between block and table? The liquid. Clear? Between the block and the table there will be liquid, right? So here there is going to be some liquid, and how much is the thickness of that liquid layer? That's given in the question. Thin layer is called film. So how much is the thickness of that liquid film? 0.3 mm, right? So if you say figure, it would look something like this. This is block. Over here there is the liquid. Any means a table. Okay, right? So it's going to glide. Make sense? Right? If પાણીમાં પગ પડે તો પગ કેવો slip થાય. Something similar is going to happen over here, right? Okay. So a liquid with film thickness 0.3 mm. So this thickness is given 0.3 mm, 0.3 meter near. Is placed between the block and the table. When released, the block moves to the right side. So this moves to the right side with a constant speed. Okay, that word is important. 0.085 meter per second, but that speed is constant. So if this block is continuously moving to its right side with constant speed, how much will be its acceleration? Zero. That's an important thing to know. Okay, so we know that it's moving with a constant speed and its acceleration shall be zero. The question is, find the coefficient of viscosity of the liquid. Based on this information, we have to find out what is the value of eta of that liquid. Okay. So we have a few things, right? We know its mass. What's the mass of this thing? 0.01 kg. Okay. And what's the mass of this block? That given? Not given. Okay. Area is given. Which area? See, can you imagine this in 3D? Bottom area is given. High area. Understood or not? So it's not given very clearly. I think bottom language. It should be bottom area. Without that, this question is wrong. You understood which area we are talking about? Yes. So change the number, right? Bottom area, or which area of bottom? Okay. Now, all we know is that this moves with a constant speed. So we know acceleration is zero. And for acceleration to be zero, what should we have? When is acceleration of some object zero? When total force is zero. Correct? You remember that? That's called equilibrium, isn't it? Right? Equilibrium means total force is zero, and that would have acceleration is equal to zero. Right? So let's draw FPD. Because this is about force, we don't have a choice. We have to draw FPD. So first of all, I'm going to draw FPD. We don't know its mass. Let's say it's m. Easy now. Okay. What other forces could be there? There would be tension. In which direction? Right side. Right? Okay. So low way. Normal. In which direction? Upward. It has to be there, right? Nature kहीं अंदर घुसी जाए ना. Correct? There will be upward force that will be normal force. You know, if you are being very pedantic, you would realize that this normal force is not really applied by the table. It would be applied by the fluid. In that case, you wouldn't really call it normal force, but anyway, it does similar action or has a similar role. Okay, now anything else? Viscous. See, there has to be one more force. There is no doubt about that. Why? N can cancel mg, no problem. But there is nothing to cancel t so far. So the acceleration is because t would never get cancelled. So total force cannot become zero. Make complete sense to you all? Yes. So there has to be some force, right? And that force actually will be due to the liquid, and you could say it is the viscous force of the liquid. Now why would this act? Let me tell you. You see, in this layer, in this film, what would happen is that the uppermost part of this layer, it would try to stick to the block, while the lowermost part of the layer will try to stick to the table. So now what's going to happen? The uppermost layer will try to move with the block, but the lowermost layer will try to stay there. So do you see that their velocities are now different? That is, we have a velocity gradient. Understood? Right? There is going to be a velocity gradient because uppermost part will try to move with the block with this. The lowermost will try to stick to the table, that is, it will try to remain at rest. Got it? So now whenever there is a velocity gradient, there is always going to be a viscous force. Fine. And the upper layer is moving towards the right side. So this lower layer will try to stop it. That's why the viscous force is in left direction. Understood? Fine. So that's the reason for that FPD to be like this. Now, let's draw F3 of t. બધાને ડ્રો કરો છે જનરલી તો છે ને કોઈ કન્ફ્યુઝન છે. ઓકે here FBD of this thing. Downward force anything mg, that is 0.01 g, correct? mg mass is next okay. And the acceleration કેટલું? અને acceleration 0. r નો acceleration કેટલું? 928. Sure? Yes. No, 0. If you have got a string, so આ move થાય એટલું જ આ move થાય ને. So suppose this has acceleration downwards, then this will also have acceleration right side, isn't it? Yes. Clear or not clear? Sure? Because if this moves 1 centimeter, this has to move 1 centimeter. String is attached to both. Clear? Spring nothing, just spring હોય તો અલગ. But we don't have that kind of complicated question here. Simple one. So whatever this moves, this will move. So if this has acceleration 0, the other one should also have 0. Right? So now, from these two FV, do you agree that we have FV equal to T, and from here we have T equal to 0.01 G? Clear or not clear? What do you think? Is it clear to you? Because if something has 0 acceleration, total force must be 0. F equal to T. This will happen not just on x axis, it will be on y also, but we are not concerned about y here. We are only interested in x. So we can say F is T. Now go to this one. Here we can say T is equal to, absolutely clear? Because once again acceleration is 0. So we put all the three equal. Now what is our aim? What do we want to find? Coefficient of viscosity. So put the value of Fv, the formula that, right? So what is Fv? Minus eta A delta V by delta Z. Is it it? And that is equal to 0.01 into G. You could take 10, you could take 9, 20, whatever. Now, let's put value delta V. As you go from upper to lower, let's say this is that film. Okay, again, just to clarify, as you go from upper to lower, how much is the change in velocity? ऊपर के लिए स्पीड है, यहाँ के लिए स्पीड है 0.05, यहाँ के लिए स्पीड है 0. Okay, so this will be final minus initial. Understood? Yes. Okay or not okay? Final minus initial. Final 0. Here 0 for 0.085. And in depth, how much is the increase or change in depth as you go from here to there? How much is the increase in depth? So that should be clear. And minus sign eta area is 0.1, I think. I hope you realize why we are taking only this area, because block is only attached or only connected to that part. But the fluid, right? If you step in and let's say oil spilled on ground or on floor, so where you place your foot, only that part is going to apply viscous force, correct? Because only that is in contact with your foot. Okay, and put the right hand side and solve the equation. Alright? Give you 1 minute to finish whatever you might have remaining. Right side में लेकिन नहीं हो दब दो बराबर. Right, without calculator as far as possible. finish it. I'm not doing calculations, leaving it like that. Okay, finish. Now let's go to the next thing. Okay. Now we are going over to this, that is Reynolds number. Some students in the other class said that it's not given in the book. Depending on whether you have a new or old book, it might be there, might not be there. Okay, no problem. You still have to do it. Okay. So what is Reynolds number? Without going into all the details of deriving its formula, it's a number that tells you whether the flow is streamlined or not. Okay, to put it in one single sentence, Reynolds number is a value that helps you decide whether the flow is streamlined or not. So, depending on the value of Reynolds number, you would classify the flow. So, if NR is less than 1000, then we say that the flow is steady or streamlined. Okay. If NR is less than 1000, I'm going to write the same thing. Don't worry. NR is less than 1000. That will indicate the flow is steady or streamlined. Second possibility is NR is between 1000 and 2000. Then it is unstable flow. I'll comment on all these three very soon. And the last one is if NR is greater than 2000. Three cases again, less than 1000, between 1000 and 2000, and the last one is greater than 2000. Okay, so in this case it's going to be turbulent. We say that the flow is turbulent. Okay, steady flow, streamlined flow, unstable flow, and turbulent flow. Alright. So what is the meaning of these things? Okay. First of all, I'll just try to give an intuitive idea of why it's like this. You see, if fluid flows in a tube, as long as it flows slowly, it's going to be predictable. That is, it will behave nicely. You would have seen that rivers or streams that go slow, their water flows just in one particular direction. Okay, and it's not random. You can wait and watch, things don't change over there. Their speed is other way, their direction is the same. That is what happens when you observe streams which are flowing slowly. On the other hand, if you think of a flooding river, have you ever seen a flooding river? There, the water just rushes here and there, correct? I'm sure you would have noted that, right? So that's a classic example of turbulence, right? Which is exactly opposite of, right? In steady flow or streamlined flow, you can predict what's going to happen at every point. That's the definition, if you remember. Streamlined flow is a flow in which the velocity of fluid at any point remains constant with that. But in turbulent flow, right? That's why it is very risky to jump into a flooding river. I hope you understand what I am saying. Because right now it might be flowing slowly, but you never know, after 10 seconds, situation could change completely. Right? Okay. So that's a very good example of turbulent flow. In general, you are going to see that whenever something moves fast, then the flow is not predictable. For example, if you open the tap in your house a little bit, you see that water will come out very nicely as a stream. Am I right? But if you open it more, you see that when water rushes out, it doesn't seem to follow a nice pattern. Right? That's the difference between this. In turbulent flow, it could go here, there, everywhere. Right? You cannot predict. Okay, so basically what happens is speed is the deciding factor. If the speed is more, it would go towards turbulence. Make sense? Because if V is high, so we study it like that. Okay, so if someone tells you that the Reynolds number is this, then you can actually get an idea of what the flow could be like. Right? One thing that you should understand is that these values are approximate. એટલે એવો કોઈ rule ન હોય. Okay, nature has not made strict criteria that if NR is even 1001, then it's completely turbulent or unstable. એવું ન. Also, staying just below the limit, like saying NR is 999, that doesn't mean that this is steady. Right? What this is telling you is a tendency. The lower the value of NR, the more steady it is. And gradually as the value of NR will increase, that's obviously because gradually V will increase. If V will increase, then you are going to get more of a turbulent flow. What is unstable? Unstable is something, a flow which is kind of mix of both. Sometimes for a few moments, for some duration, it will remain steady. And then suddenly things will change and it will become turbulent. પાછું change થઈ જાય, પાછું steady થઈ જાય થોડી વાર. You understood that? So it alternates or it switches between steady and turbulent. And so that's going to happen in medium range of velocity. In very low speeds, steady or streamlined. So whenever liquid moves slowly, it's very likely to be streamlined. Whenever it moves very fast, it's going to be turbulent. Understood? Okay, so that's what this Reynolds number is about. Again, like I said, we are not going to derive it. Right? In those books in which the derivation is given, you can see it if you want, but it's absolutely not important from any point of view. Right? Okay. અને એટલું બધું fluid mechanics માં deep માં ખરેખર જવાની જરૂર છે. Right? It will create more questions than it would answer. Right? And that's in fact the reason they would have removed this from the syllabus. એટલે ઘણા બધાની બુક્સમાં નથી. Right? Okay, never mind. So remember what I told you, that these values are only approximate. આ કઈ strict criteria નથી. એટલે કોઈ એવું નહીં પૂછે સર 1000 હોય તો inequalities મને આવડે બરાબર, તો એવું equal to નથી લખતો, because there is no need. These are only approximately true. That is, these are ranges. એટલે 1000 આજુબાજુ હોય તો steady flow. That's what you understand. Right? Okay, so don't ask what happens if it's exactly 1000. We'll still say it is steady. Right? Okay, so that's what is Reynolds number. Another thing related to Reynolds number is critical velocity. Okay, same topic है, अलग लगता नहीं. So what is critical velocity? It is the maximum allowed or possible speed of fluid or velocity of fluid, if you are writing velocity, is the maximum allowed or possible speed of fluid or velocity of fluid for steady flow or for streamline. Okay, what that means is, if the velocity is more than this, the flow will become unstable. Understood? Right? So this is the maximum possible speed for which it will flow steadily. So if you want to find out how much is its value, well, it's very easy to do. Take 1000. Right? Okay? You get this. Yeah. One thing that I actually didn't mention, I'm so sorry, D. What is D? D is the diameter of pipe in which it is flowing. Right? So let's put down the terms also very clearly. If you have space, you can write it just next to it. બીજી terms તો તમને આવડે જ છે ને? width or diameter of pipe. Alright, width or diameter of the pipe in which it is flowing, right? So why did we get 1000 in here? I am putting the limit, NR is 1000. Let's put it like that. So this will give you VC equals 1000 eta by rho. Is this exact? No. એટલે આ શું છે ખબર છે, એક પોઈન્ટ છે, આનાથી દૂર રહેવાનું, then the flow is going to be streamlined. For example, this VC turns out to be 20 meter per second. Okay, and let's say you want to design a pipe or design something in which fluid flows, and it should be able to flow predictably. You understand what I mean? It should be able to flow predictably. Predictably, that is, it should be under your control. એવું નહીં કે ગમે ત્યારે ઓછું વધુ આવવા માટે. Then it has to be streamlined. So you should keep the speed of the fluid less than this, and you should also keep some margin, because like I said, this is not exact. પછી તમે એમ કહો કે સર મેં તો 19.99 આવે ને એવું બનાવ્યું હતું, પણ હવે સ્ટ્રીમલાઇન નથી થતું, તો એ તો નો જ થાય. You understand? So you should understand it's not really an exact value ever, right? આ બધું fluid mechanics માં રહેવાનું, because it's regarding material, right? Okay, so you should stay away from it. Basically 20 હોય તો 10 જ રાખો, stay on safer side, right? So suppose you want to actually make an instrument or some machine that can do it very nicely even at 19.99, then it will be costly, because it will require precision. You see, this, I think this is a very good point to explain the importance of precision. Suppose you want to make a door, let's say, right? So ખબર તો બધાને છે કે ડોર એટલે રેક્ટેંગલ બનાવવાનું અને આ સાઈઝનું બનાવવાનું, બરાબર? મોટું ન બનાવાય ને, આ જે ફ્રેમ હોય એની સાઈઝથી મોટો ડોર બનાવાય. કેમ? શું થાય મોટો બનાવો તો? હે? બંધ જ ન થાય. વેરી ગુડ, યુ આર સ્માર્ટ. ઓકે, તો નાનો બનાવાય? કેમ નાનો ન બનાવાય? You understood what I'm saying? So when you make a door, પૈસા કેટલા છે ખબર છે? આ ગેપના જ પૈસા છે. I'm sure you realize that whenever you close the door, there is always going to be a small gap. આ gap જેટલો નાનો ને એટલો કાર્પેન્ટર સારો છે. You get what I said? Right? બનાવે તો આપણે બનાવી નાખીએ, એટલું જ થાય. We try to be on safer side, don't you think? સમજ પડે કે નહીં? આપણે એમ થાય કે બંધ નહીં થાય તો નાનું કરી નાખો પહેલા જ, એટલે કોઈ ટેન્શન જ નહીં. Got it? But that doesn't work either. એટલે એન્જિનિયરિંગમાં આવું જોઈએ. Whenever you want to design things, you have to have a tolerance or precision. Door બનાવવાનો હોય તો એની સાઈઝ સપોઝ let's say this is 1.5 meter. So 1.5 meter plus or minus એટલામાં જ બનાવવાનું. You get that? That is what is precision. Got it? બહુ વધારે નાનું ન ચાલે અને બહુ વધારે મોટું ન ચાલે. So if you are designing something where you want 20 meter per second, right? એટલે એનાથી ઓછું તો કોક તો એવું બનાવે 1 meter per second વાળું મશીન, પણ જે 20 થી કામ કરવાનું હોય એ 1 માં ક્યારે પૂરું થાય? Let's say you want to deliver a fuel to suppose an engine, let's say, so ekdam practical vichar. Suppose you want to deliver fuel to an engine. The fuel to engine ne predictably જોઈએ ને, એવું નહીં કે આમ અચાનક આવ્યો ને પછી બંધ થઈ ગયું પછી પાછું આવ્યું. You get what I'm saying? So to be on safer side, suppose you don't use 20, you use only 1, extremely safe. So પછી શું થાય? Your engine is not that good because it cannot draw that much fuel. તો એટલો પાવર ન આપી શકે. પછી તમે ગાડી બનાવી હોય મોટી અને ચાલતી હોય સાવ નાની સાયકલ છે. Get it? So to make it better, you have to go close to 20. But the closer you go, the more risk there is, and you have to design it very precisely. તમે બરાબર બધું સેટ કરો તો વાંધો ન આવે. ક્યાંક જરા આગળ પાછું થઈ ગયું, પેટ્રોલમાં થોડો કચરો આવી જાય તો બધું કેલ્ક્યુલેશન બગડી જાય. So the closer it is to the limit, the better that instrument is, and that means you have to be more precise. એટલે એવી વસ્તુ મોંઘી. For example, let's say you are designing tires, let's say, and when you apply brakes, right, so the tire ni grip રહેવી જોઈએ ને, બરાબર? And suppose you are using some material, rubber, let's say, which cannot be broken for some given stress. Stress yaad છે? For example, that stress is 10 raised to 7 Pascal. હવે ઈ તમે એવામાં નાખો કે જેમાં એને exactly 10 raised to 7 stress સુધી આવી જ જતું હોય, then you are operating on the limit. એટલે કોક દિવસ કોક બચી જશે અને કોક દિવસ કોક નહીં બચે. But suppose you try to stay on the safer side. Like you put a limit કે અચ્છા 10 raised to 7 Pascal છે, પણ આપણે છે ને 10 raised to 6 Pascal થી આગળ નહીં જવાનું. એટલે you are keeping a margin of 10. Then you will not be able to advertise your product for bigger vehicles. સમજ પડે કેમ? Because generally the bigger the vehicle, when you apply brakes, there has to be more stress. Neither ઊભું જ ન રહે. Make sense? So you will have a loss. So તમારું આ ચાલશે. So what to do now? Try to go close. And when you do that, when you try to go close to the limit, you will have to make it very nicely. બધું ધ્યાન રાખવું પડે during manufacture. That means the cost will increase. Very simple. This is exactly how everything works. બાકી દરવાજો તો હું બનાવી નાખું, તમે બનાવી નાખો, બરાબર ને? So that's it. And you see, that's the advantage of machines. Machines that can make such structures, they can be very, very precise. You understand what I'm saying? Only a very, very skilled worker can make it more precise. બાકી આપણા જેવા લોકોનું તો કામ જ નહીં. તમને એમ કીધું કે આ પાઇપ છે અને આટલો કટ કરો, let's say they say make the length 2 centimeter. તો તમે કાપવા જશો ને તો 2 centimeter ના બદલે 1.8 થઈ જશે કોક વાર, ને કોક વાર 2.3 રહી જશે. But a machine can do it very nice. Right? That is because we are unskilled. So in engineering it's all about this. તમે સેફ રહો તો સેફ રહી જ શકાય, પણ પછી સારું ન બને. Got it? So this is more like what we have in practice. Fluid mechanics actually is a chapter. Fluid mechanics is not like the other chapters in your book. For example, laws of motion. There you study what really happens in nature. In fluid mechanics, the focus is a little bit on what you can do with the fluid. એટલે એને applied science છે. શું કહેવાય? Applied. Previous chapter, properties of solids, is also applied science. Laws of motion is pure physics. બરાબર? Pure physics એટલે ખાલી theory એવું નહીં. But pure physics means whatever you are studying over there, there is only one aim. That is to understand what is happening in nature. એ ચેપ્ટરમાં કોઈ દિવસ આપણે એવું ટેન્શન લીધું કે આ ફ્રિક્શન આવે છે એનું આપણે શું કરશું? કંઈ વાંધો નહીં, કંઈ નથી કરવું. But first you try to understand how friction behaves. Is that clear or not clear? Yes. That's the difference between pure and applied. Right? So some chapters in your book they are pure, and some chapters in your book they are applied. એવા બે પાર્ટ્સ હોય સાયન્સના, બધામાં હોય, કેમેસ્ટ્રીમાં હોય. Right? Okay. Fine. So that's what we have about critical velocity. Reynolds number બધું યાદ રાખવાનું છે તમારે. Don't forget. We don't have a lot of time now. બધું મેં તમને કીધું એમાં ટાઈમ જતો રહ્યો. So I think we can solve one question though. Example છે regarding Reynolds number. with 10. अच्छा તમારી બુકમાં તો રેનોલ્ડ નંબર ટોપિક જ નહીં આપે તો એક્ઝામ્પલ ક્યાંથી આપે? બરાબર ને છે, but everyone wouldn't have it, that's why. How many of you have this example 10.11? આમ તો 11 તો બધામાં હોય કે નથી? Okay, the example 11 is here in this book is flow rate of water. એવું છે? How many of you have it? How many of you have that? Okay, and the others don't. Right. Okay. Example પૂછા છે? Who asked that? પૂછું ને? નો પૂછું? It's actually easy, don't you think? બોokમાં નથી. ના, તો JEE માં તો પૂછી શકે એટલે હું તો કરાવું. બરાબર? Okay, so those who don't have it, you can write the details of this question. Time એમાં પૂરો થઈ જવાનો છે. So this is an, for people who don't have it, this is an extra example for you, right? It is given that water is flowing in a tap with diameter 1.25 centimeter and it is volume flow rate is given. What is given? Volume flow rate is 0.48 liter per minute. સીધી રીતે SI યુનિટ માં આપવામાં કઈ વાંધો છે? Coefficient of viscosity is 10⁻³ pascal second. આટલું કરી નાખો ચાલશે. Okay, so this is it. I think if I give it to you, you will be able to do it as well. એમાં કઈ છે? This is data. You have to say which type of flow is it. You have to say which type of flow. 1, 2, 3. How to decide? Calculate which thing? Reynolds number. પછી જોવાનું એની વેલ્યુ શું આવે? This or this. Method clear? Only one point that I'd like to help you. Ajo. Is speed given? We are given volume flow rate. We are not given speed. આમાં બધી ટર્મ તો ખબર ને? Rho for density, V for speed. જો capital નથી. See the difference. D for diameter, that I have already told you. Eta, you know, is coefficient of viscosity. So, from volume flow rate, how to find speed? Is there a relation between volume flow rate and speed? Volume flow rate is area into speed. A into V. You remember that? બસ એમાં મૂકી દો તો મળી જાય. Absolutely clear. How to find area? Diameter આપ્યું. From diameter you can find area. Correct? Sure. Unit શું? Is liter SI unit? What is SI unit of volume? Meter cube. So 1 liter you have to convert to meter cube. આવડે ને? મિનિટ તો આવડે, સેકન્ડ માં કન્વર્ટ કરતા. there is no doubt about that. થઈ જશે. So find V first of all. By doing all this, find V and then put it in this formula and see what you get. Okay, જો મને answer. કાલે. All right. Goodbye. Thank you.